All right. Hello. Good day, everyone. And welcome back to another session of our path to building a SaaS. Just checking the stream very quickly and the audio as well, just to make sure that everything is in order. All right. Um, okay. We're set to get going, or at least continue on our journey. So this week is going to be a little bit different. Because what we would want to start doing now is really start getting ready to build our SaaS. And of course, like in the last couple of weeks, we've hopefully already built some foundational components of our SaaS. However, as we will now start to gear up to actually start building using our chosen tech stack, we will have to redo most of that work. However, considering that we are now going to firstly plan our approach, secondly, um, utilize a lot of pre-planning that we will also be using our AI models for, as well as putting in some structure in order to allow us to do that very, very quickly. All right. So today we're going to start to again review some components or some of the bits that we spoke about last week, as well as continue to talk a little bit about databases. We're not going to do too much of that today because that's going to be kind of the last component of building our application. So we're just going to cover the databases, and specifically the one that we're going to use, and we're going to compare it to the one that we're not going to use. At the end of the day, you are free to use whatever you want. We're just going to stick with Supabase for the build, just out of simplicity and standardization, right? But I do want to share with you the options that you have at your disposal, so that you can make the choice that works best for you. All right. So having said that, let's get cracking. Um, all right. So last week we covered the backend in JavaScript, specifically using Node, and we're going to dive into that again today. So again, like we've made the distinction between front end and back end multiple times during the course. However, when we start to talk about the back end and what it does, it really solidifies the major difference, because your front end is everything that you build just with like your CSS, with your HTML, CSS, and JavaScript for the front end, like the page that the users will interact with, even if you build dashboards for yourself or web pages to manage your SaaS, right? All of these are considered front end components. The back end is where all of the logic comes into play. And in order to run JavaScript in the backend at all, right, where JavaScript was initially created to run in the browser alone, um, we have something like Node.js, which is not the only option. So today you have other popular alternatives. However, Node.js is still most widely used and supported backend framework, or library for JavaScript, right? So it's an environment that runs JavaScript in the backend that allows JavaScript to do things that it can't do in the front end. Because in the front end, the JavaScript is running inside of the browser, and the browser has limitations imposed onto it by your operating system or many other security aspects. When we run JavaScript in the backend, we're running it more as a native application, which has access to talking to memory, talking to your CPU, GPU, all these kind of things. It also uses an event-driven architecture, which we'll explain in a bit. It is still single-threaded, however, because it offloads many of the tasks that takes time to the OS or to other components of the system. It doesn't, or it shouldn't. We should generally avoid our application running tasks that take a long time in order to not create a freeze in our application, right? So the event loop for JavaScript is quite complex, but we're going to put it very simply for our use cases. We have requests that are coming from the front end, right? As they arrive in the back end, they will enter a queue, right? And every new request that comes in will be at the bottom of the queue, right? So it will be the last request that will be handled. So everything that was there already will be handled before this new request will get its turn. If the JavaScript engine in the backend sees that, okay, this is a task that requires time, so it requires to query a database, it requires to write something to memory, read something from memory, it will execute that task, put it on a callback stack, and then wait for that operation to finish. But it will continue to handle other requests coming from the front end. When the reply is ready, so let's say you wanted to read the database to retrieve some user information. As soon as that information is available, there will be a trigger that will present that information again to the JavaScript engine. It will process that information based on the requirements, and eventually that information will make its way back to the front end, right? So this is the event loop. There are many examples, and there are some links that I will share for reads in order to better understand the event loop and how it works, because it can cause some issues, or there are some things that you might need to understand about how it works in order to troubleshoot certain events in your application that might not function like you expect them to, right? So to also explain the prioritization of the execution of tasks. So here we have three statements that are just being printed to the console, right? So it's a very simple test. We have the first statement, right, with just a simple console log. Then we're running a timer function. So basically, we are wrapping the console log in a timer function where we're saying, okay, we're delaying the execution of this function's execution by 1,000 milliseconds, right? So it's just 1 second. And after that, we have another console log. That's the third statement, right? So when this runs through the event loop, this one will be printed immediately, right? Because it's something that doesn't need to be offloaded to any memory handling or processing structure, right? So this is something that JavaScript can just execute immediately. The second one is going to be like, okay, this is a function that we're going to call. It's going to cost some time. We're going to put this on the callback stack and then come back to it when it's done. And then it will execute the third component, which is again a console log. And this one will be printed immediately again. And after that alone, it will return back to the call stack where this one will be picked up because the timer would have then expired. And then it will print the second statement. So you will have the first statement, the third statement, and then ending with the second statement. All right. We went through the installation of Node.js just briefly. We're not going to cover that again during the review. And then we spoke about npm, which is the Node Package Manager, right? So the package manager is used to install all kinds of libraries and frameworks and tools in order to help develop things in the backend using JavaScript. So there are many different libraries and frameworks that you will utilize while developing the backend, and you will see that growing rapidly when you build your application as well. All right. In order to keep track of all of these, there is a package JSON. That is there by default when you install npm, and this will have basically a manifest of all of the different files or components or libraries or tools that you have installed. their name, their version, at least the minimum version that needs to be used, so that later, if you store this project in GitHub, which we'll cover today as well, and at some point later down the line you want to redeploy this project, maybe on a different computer altogether, this package.json file will basically tell npm all of the different applications that need to be installed in order for your app to be fully functional the way that you designed it during that time. I do want to highlight though. So whenever the package.json is run, right, and it installs a whole bunch of dependencies, there is a risk. There is quite a big risk that some of the dependencies that you're using are too outdated and you have to renew them, right? So it will install a newer version for you because the version that you used to use is considered insecure or incompatible with whatever other application that requires it. And this will generally break something in your application to where you have to go and troubleshooting mode and understand what changed, what kind of changes do you need to introduce into your application in order to get it working again. So this is just something that you need to be aware of, that if you store an application for a while and then get back to it and want to redeploy it, the first thing that you're going to do is to deal with all of the broken components in your build. All right. There are a couple of commands that you would run normally with npm. So you can initialize a project, you can install a package, you can start a package or start a runtime. All of these we will run through quite frequently as we make our build. So this is an example of the package.json. All right. Now, as a part of the backend, we of course need to run a server in order for our front-end requests to be answered to. This is again something that we did last week, and we can show that off again a bit later on. And then, of course, we spoke about RESTful APIs and their principles. So at the end of the day, just like we established, you have the front end, which is visible to the user. And if there is any function or anything that needs to run or happen when the page loads, when a user clicks a button, if something is updated on the page, your backend will need to have APIs available so that the information can either be requested by the front end, information be delivered from the front end to your backend, updated, or maybe deleted. And this is where your REST API comes in, so that you can provide methods in your backend that will dictate what happens with the information that comes in from the front end. So whatever users do on the UI, how that translates into any kind of update in your application. Right. So, like already mentioned before, right? So the backend environment of JavaScript, in this case Node.js, allows JavaScript to read and write files. If you remember when we built our simple Kanban board, you know that we created an ability using JavaScript to output our tasks to a JSON file and then re-import them so that we can store these somehow, right? Because again, our application, because it's running in the browser, if we're doing only the front end, it can't just save it to a file directly. However, when we're running JavaScript in the backend, or at least as a separate application from the browser, it can, right? So it can write to files, it can update these files, and this is why Node.js also has a file system operations module. So that's a function within Node.js that's already built in that provides you the ability to read, write, and append files and delete them as well. All right. And also we spoke about how for us, if you're starting out with doing all of this, and even for experienced developers, that AI specifically can be of great help. because a lot of these things in configurations are quite well standardized. So if you need that kind of deployment or that kind of configuration, as long as you know what it is that you are planning to configure and how that should work, AI can do most of the work on your behalf, which is really great. Okay. We did a bit of a comparison between all of the different tools that are at your disposal. I don't want to spend too much time on this, but I will go through these very quickly. Just give me 1 second. Yeah, okay, I still got these here. Just a moment. Okay, so to put it very simply, if we go back to our AI model comparison, right? So we have GitHub Copilot, which we've been using now by default while using Visual Studio Code, right? So it's something that's already embedded into Visual Studio Code. You don't need to download any kind of other application for it. There is a free tier, so far, at least what I've shown you, all of it has been just using the free tier of it. So I haven't really created anything. So if I'm just going to start a new chat here, you can ignore all of these files. If I just click on this GitHub symbol down here, you can see that I've barely used anything from either the chat messages that are available to me, as well as the code completions that are available to me. Again, I don't use this actively outside of doing these streams. So if you're really going to start using this to build an application, you will see that it will accumulate quite quickly. I will start to do that today using this environment. So you will see that as well being reflected here in the next week, or at least the next weeks. But getting back to the comparison, right? So there are AI models that you can use in your IDE, right? So your integrated development environment, which is what Visual Studio Code is, right? Now, GitHub Copilot used to be much more limited. So now you can also use different AI models that are being provided by different companies, which did not used to be the case. And you can even add more if you have API keys coming from other ones that you have subscribed to or you have free access to due to having any kind of company paid subscription, or you're subscribing to Gemini Pro, for example from Google. You can enter these and use them separately, right? Still within Visual Studio Code. Other options are using Cursor. So Cursor is a fork. So this is basically also Visual Studio Code, but basically changed for the way that Cursor thinks that it works better with AI. So it's like fully AI driven. And again, you have a free tier that gives you some free requests, and you have a paid tier that will give you many more. You can use, I don't have it open here, Windsurf, right? So Windsurf is similar to Cursor, but it functions a bit differently. So it's again like nothing super different from Visual Studio Code, because again, this is a fork of Visual Studio Code. It will look a bit different. It will function slightly differently, but it will be a very familiar experience if you've already started to use Visual Studio Code, and then either move away to Cursor or to Windsurf. And again, like in the past, Cursor and Windsurf were, or at least became, very popular because Visual Studio Code and GitHub Copilot didn't used to offer you many options in terms of using different AI models, but now you can. But moving away from these like dedicated applications, so you install these on your computer, you're using them as your development environment, right? Like I'm doing here. So if I'm using Visual Studio Code, I have all of my files, I create these, I can like manipulate them in here. But I can also use AI in order to say that, okay, I want to add this kind of functionality, or I want to change something, I want to update something, right? And it can do that for me. So all of this is local, right? But also you have, if we go back to the slide very quickly, right? So these are your IDE. So these are actual solutions that you install locally and use them, right? There are also add-ons. So there are also things very similar to Cursor that you can install, that you can add to your VS Code environment, that will change how it behaves and how it functions, separate from GitHub Copilot. In here are some examples of these. But then you have the web-based IDEs. So the web-based IDEs are, sorry, no, not here. These are things like lovable.dev. You have bolt.new. And you have Vercel. And Vercel specifically is, or at least V0 by Vercel. And all of these provide you basically a way to build your application just by prompting their AI in your browser. So you don't download any application, it's all in here. And at the end of the day, there is the main difference is, right? And for me, the reason why I don't use these for any project that I actually want to build and complete and deploy online is for a couple of reasons. And again, these are my reasons. You can think of this very differently. You can make different choices. It's all up to you. So for me personally, right? If I'm going to develop an application, I want to be free in choosing the framework that I use. So what kind of front end do I want to use? What kind of backend do I want to use? What kind of database integration do I want to use? What kind of other websites and services do I want to maybe integrate into my product? That I want to, again, be free in choosing that, right? So this gives you full control, where if you do that with a web-based environment, it will have its own tech stack. So it will have its own front end, its own back end, which are again based on JavaScript libraries. So this is not something that they developed because, again, like there is no purpose for them to develop a fully bespoke environment. They will integrate with some services, with some databases. They will integrate with some like how do you call it, authentication methodologies that you can add into your application. But again, you kind of have to use what they provide you, right? And there is no way for you to change that because that's just the way that their AI builds the software. The same goes for Bolt, the same goes for V0 and any other alternative, right? So when you start building here, you're kind of firstly building on their tech stack, and secondly becoming more dependent on whatever options they provide you, rather than choosing them yourself. And then there is the second big one for me is the cost perspective, right? So all of these, they give you very, very limited free tier. So if you use Cursor or GitHub Copilot or whatnot, you can use quite a lot. If you're building a small app, you can build your entire application without paying anything. If we look at Lovable, you get 5 daily credits. So you can prompt 5 times a day for free. And that's just not simply not going to be enough. If you're really trying to build an app, you're going to need much, much more than that. And then to upgrade isn't that cheap compared to, GitHub Copilot, Cursor, Windsurf. And the big disadvantage here for me still is the fact that you don't have the ability to choose what kind of AI you want to use for your build. So it just uses whatever it uses. And, if that works for you, great. If not, then, tough luck. And the prices are quite high, to be very honest, for me, in my perspective, right? If we go to Bolt, it's the same kind of thing. So if we go to pricing, again, you have here you have like a token count, which also is utilized very, very quickly. I've also tried all of these and tried to build mini apps in them. And to be honest, they're great for ideation. So for me, it's great to just jump in here and put something together in a couple of prompts, just as a proof of concept. So it won't be functional because not most of the things that you see on the interface won't actually do anything. They won't be linked to anything. And if you already want to continue with that, you're going to spend a lot more time and money in order to complete the application based on these platforms. Well, that's the whole point. So basically, they want to create a very easy entry point for you to start playing around here, provide your prompt. And then once you get to the point where you're like, this looks good, I want to continue building my app here because I like the way that it kind of has built a user interface and user experience for me. But in order to actually do that, it will become quite costly, right? And the same goes for V0, right? So you get very few free credits, and then you're expected to start paying for it. And even if you pay for it, then your application becomes a bit complex, and you need a lot of requests on a daily basis in order to continue. You're going to have to upgrade in order to make it out. Where if we look at, for example, the pricing for Cursor as well as for Copilot, if we scroll down here a little bit. So for Copilot, which we already have by default inside of VS Code, you get a free tier, so you get 50 like requests to the agent, right, per month, which is again like not a lot, but if you're building like a small app and you pre-plan what it is that you're building, you could still get quite far just by using the free tier. The completions are wherever like it auto completes your code for you. You can turn this off, you can use it, it's up to you. And it provides you with some of the models. Now, if you can start paying for just $10 a month, which is significantly cheaper than all of these other ones that we saw, it will give you quite a lot. So you get unlimited use of the agenting mode, which is to be honest just unbelievable value for money at this point. You're still not going to be getting all of the AI models, so there are some expensive ones that you don't get in here. And if you want them, then you have to upgrade to the Pro. But again, if you're building a relatively how do I say it? If you're not building a very complicated application, you will most probably not need that, right? But if you are, then the cost wouldn't really be a problem for you, right? Again, if we look very quickly at Windsurf, very similar pricing, although maybe, actually not maybe, it is more expensive, but still provides you more freedom. So you have a free tier, which gives you some prompts per month for free. Something that you don't see here is that there are some models that are free altogether. So outside of these prompts, you can like use certain models just for free, and that's it. And some of them are like every request won't cost you one full credit. So there are models that only cost half a credit or quarter of a credit to use. So that means if you use one that uses half a credit, you're going to prompt 50 times. But then if you upgrade for $15, you get 500 prompts per month, which is quite good for building small SaaS applications. And then you can also grow it from there. And if we very quickly just look at the pricing for Cursor, yes, okay, thank you. You have the free tier. You have then the Pro model for 20, which doesn't say specifically how much you get, which is a bit of a strange pricing, but it is significant, a bit comparable to what Windsurf provides you. So they give you more like bang for your buck, but then the trade-off is that for most people who have not built anything yet or haven't built anything before, the barrier of entry of like, now I have to install a code editor and I have to manage my files locally and I have to push it to the cloud at some point, and how do I do that? This hurdle is already enough for a lot of people to just want to stick with using Lovable or Bolt or V0 or any of the alternatives, while they are significantly more expensive to use month in and month out. All right, but you're here, right? You're a part of Humble Devs, so we got you covered, and we're gonna hopefully get you there without paying anything. And if you do end up subscribing, then that's perfectly fine. At the end of the day, there are some tools that are just simply necessary. And if they can provide you with a lot of value, then for me, from my perspective, paying the relatively minimal cost that it is being asked from you is not too much if you're serious about building your SaaS. All right. So I said I won't be talking too much about it, but I did in the end. Apologies. Okay, so full control. You can work offline. Very powerful tooling. Choose everything for yourself, right? And you don't have to put your entire code base in someone else's infrastructure, right? If you're using the online tools, you're putting all of your code basically in their infra. And if it's unavailable, if it's currently not working well, then you can't even work on your project even offline without using AI, right? Which is something that I experienced myself a couple of times. So yeah. And again, like there are some advantages to using the online ones, of course, right? So it's very accessible. You can just visit the website and you start. It might make it easier to collaborate with people if that's something that you're looking to do. But again, for me personally, the drawbacks are far more important and too limiting from my perspective to warrant using them as like the de facto way of building your application. All right. So this was a bit of a practice for using Node.js. We went through this last week. We might be covering that again as we continue. But there are a couple of things that I want to cover first, and then we'll start on a brand new fresh build that will take to completion, hopefully. All right. Today's topic, or this week's topic, is going to be covered in a relatively simplistic manner, simply because there is really a lot that goes into dealing with databases, and I don't want to overcomplicate things at the moment. So we're gonna breeze through it, right? Just to give you a very brief overview. And at some point, while building our app in the next couple of weeks, we'll have to start setting up Supabase. We have to write our schema. We'll have to connect it up, and we'll do that together. So I'll do that live on a stream so that you guys can follow along and see everything that I'm doing. So that it kind of eases you into it and doesn't overwhelm you with all of the things that you kind of have to deal with and understand how they come together at the end, right? So where do databases come in, right? So while we are building our SaaS, right? We spoke, of course, about our front end, right? So these are the devices that will interact with our application. We spoke about our backend. We have our code, right? We have the network that drives it, all of the things that are connected to one another somehow, right? We spoke, of course, about the client server model all the way at the start, about networks, about the internet in general. And if we want to store information persistently, we have to use a database for it, right? So the database of our choice isn't all that important, to be very honest. You can choose whatever database you want. But there are a couple of providers for online databases or cloud-based databases that are just very established, that provide you with generous free tiers that you can use to build your project and host it without requiring you to pay before making any kind of significant use of it, right? So the purpose of the database is to store our information persistently, right? So if we go back to the example of our simple Kanban board, right? So this is the one that we are using. At the end of the day, if this was a real app, right? So if this is a SaaS that I'm going to build out, and I'm going to give the ability for users to come to my SaaS and to sign in, and manage their tasks in here, right? So they're going to come here on a daily basis, create tasks, update tasks, get rid of them, right? All of that information needs to remain in here all the time, right? And this is where the database comes in. So for now, we're writing this to a file, which is great because I'm doing everything on my computer, right? However, if you expect hundreds of thousands of people to use this application, then this needs to be somewhere first where it is stored persistently, but also that it can scale, so that if you have a lot of users using your application, that your database is able to handle the all of the requests that are coming towards it, right? That your data integrity is being maintained, that whenever all of the updates are coming in and going out from your front end to your back end, that all of this is handled properly, that there's no data loss, right? So all of this is important. That's why we use these databases. And there are two kinds of databases that we would refer to in general, which are relational databases, also SQL or SQL for short, and non-relational databases, or NoSQL, right, for short. And the main difference is that in your SQL structured databases, there is a schema that has to be defined, and there is a strong relationship being put between the different tables in your schema. In your non-SQL database, it is more file-based, so you still create your like tables, right? But they don't have to be connected to one another. So you can like um, it's more flexible in the way that it's set up. You'll see that when we get to use it at some point. But we're going to focus mostly on using SQL-based databases, and that's primarily due to the host that we're going to use, right? So the very simple basics of SQL databases and Supabase, which is the platform that we're going to use. And also, I want to be clear: it is Supabase, not Superbase. This is not a typo. So if you look it up, or if you want to visit the website. So SQL itself stands for structured query language, right? So it's very, very simple. We'll need to define our schema, and this is where AI comes really, really in handy, because if we're going to build our app and we're going to define everything that we want to store in our application, then we just basically need to ask the AI to write our SQL for us for Supabase, and it will do just that, right? So we don't have to learn. This is one of the biggest reasons why when we cover MongoDB, that MongoDB and MongoDB Atlas is very popular in like SaaS development in general, because you have libraries that will enable you to write everything for MongoDB just using JavaScript. So you don't have to worry about learning another language. Well, with SQL, you have to learn to write a bit of SQL in order to write your schema, write your requests to your SQL. But now that we're using AI, and like most of it is fairly standardized by now, you can just simply define everything that you're going to store in your database and ask the AI that you're using to write your schema for you, and it will do that. And it will even like evolve it over time, because it's very possible that, okay, you now have a scope, you add a bit of functionality that requires a new table to be entered, or just a new row in your table to be entered to store more information. And you can then just ask the AI to add this to your schema, and then you can just update your schema in your cloud database, and you're good to go, right? So it provides us with methods that we can use. So you can select information to retrieve any kind of data. So if a user logs in, you will then create a request to your database to get that user's information, right, and no one else's. You can, of course, add entries or data to your database, update it, and delete entries. And this is just a very small like schema, right? So this is what the schema looks like. So you create a table, you say, okay, I want to create, and this is the SQL language basically. You say, okay, I want to create a table, and the name of the table, and then sort of a function structure, or like a JSON structure, where you create, okay, we want an ID, which is going to be serial, and is going to be a primary key. Again, these are all functionalities of JQL that we're using, or SQL that we're using here. You're going to say, okay, this is a cars table or database where we're storing the make as a text with a maximum of 50 characters, and it cannot be empty, so it cannot be null. The model is the same, and we have a year which is an integer. So this is all of these are entries in our database. And then we can insert data in this kind of fashion. So again, we're going to say, okay, we're going to insert into cars, which is the database that we have, which takes all of these values, and then we provide what actually we want to enter. Right? And for selecting data, so getting data from it, updating data, and deleting data. Okay, but again, nowadays we don't really have to worry about writing this all for ourselves, but it's important to know how this works. Okay, so the other option that we have at our disposal, which we are not going to use, so we won't be like diving too deep into this, is MongoDB. Which is a non-SQL database, as mentioned before, right? So this is more on like file-based. It will look somewhat similar if you look in the backend. So you still have like tables and entries and whatnot, but there is no. You don't have to set relations between everything. So you can just create a table or a document, as it's referred to, and just write things to it. And then if at later some point you want to connect it to something else, then you just do that, right? Okay, so NoSQL is simply just not only SQL, right? That's what it stands for. And we won't be diving too deep into this. I just want you to understand that you have these options, and if you want to look into MongoDB, you can. They have great documentation that will guide you into integrating with MongoDB if that's something that you want to dabble in. And it also provides a free tier that you can use, but definitely not as feature rich as Supabase. It of course offers us the same kind of functionality of like reading something, writing something, updating, deleting, all these kind of things, and using libraries for MongoDB, where Mongoose is one of the most popular ones. You can basically do all of the scripting for interacting with MongoDB in JavaScript, which just makes it generally, if you have already learned JavaScript and know how it works, then you don't need to worry about learning something else in order to manage your database, right? So yeah, you create a document. So basically you create a structure of a document of how it's supposed to look like. And then you can basically just set up a connection to it and do your queries, right? So you can say, okay, I want to find something, I want to create something, I want to update something. Relatively straightforward, right? You do need to set up a connection, of course, for any database that you're going to interact with. This is just a very, very small sample. There are different methodologies of connecting based on the kind of database that you are like referring to, whether this is an object relational database or not, or a document relation. This is where the different namings comes in of ORMs or ODMs. So if you see these, just know that the ORM stands for the relational database, and the ODMs stand for the document mapped databases. But again, you can always look these up if you really need to. And for both, you have libraries or plugins or frameworks that will enable you to easily talk to them because they provide a lot of abstraction. So there is maybe a lot of code that needs to be written for you to request something. But if you use a library, that will just allow you to write, okay, I want to get this, right? And then it basically handles all of the backend code for you to get that information that you're looking for, right? And we'll see much more of that when we actually put it into practice. All right. And both of these, so for MongoDB as well as Supabase, they provide for us a SAAS that we can utilize in order to have our database that is already online, that is based in the cloud, that we can reach and our users can reach from wherever they are. Because if you're going to, for example, host your own database, which is perfectly possible, right? You're going to have to host it on a server or like a computer that needs to be on 24/7, connected 24/7. And if your users are trying to reach it from the other part of the world, this can be a very slow experience for them because it might take some time for your database server to respond to the request and to send the information back to them if the information is significant, right? And this is where the SaaS world becomes then very powerful for you developing your own SaaS, because then you can tap into the infrastructure that has already been put in place for these kind of solutions, right? So MongoDB has something that's called MongoDB Atlas, which is a like SaaS that hosts MongoDB for you online. They have a free tier which you can sign up for, that will allow you to use basic MongoDB functionality for your application totally free, right? With limitations, of course, but if you're building a small SaaS, that should be more than enough to cover you. Supabase does the same, but again, is very different because it's SQL based, which is so it is open source. It is an alternative to something called Firebase, which is more of an enterprise level SQL solution. Firebase itself can also be used for free, to be honest, but it is quite more complex to set up because again, it's meant more for enterprises. So we're not really going to dive into using that. But it provides you a lot of functionality. It provides you your database. It provides you with authentication, so you can just have your complete authentication go through Supabase, and as well as add social login. So you can even enable logging in through Google, logging in through Microsoft, logging in through Apple, logging in through all kinds of social media platforms, all from Supabase itself. It also provides storage. So if you want to, for example, store information, pictures, any kind of like reference material of your application in the cloud, then you can do that as well. And it can also run functions, because this is one thing that we haven't really touched upon. But at some point while you're building your application, there will be some functionality that you need to trigger. So if a user does something on your front end, right? You might want your backend to validate something, or update your database, or retrieve something from database, again for validation. All of these things have to run, but we don't have a server dedicated to running these tasks. And this is where Supabase also provides you the capability to script out certain logic that will run based on a trigger coming from your application, which is very, very powerful, and which is really, really needed to get our SaaS fully functional, as you will see as we continue on this journey. All right. As a last remark, the Supabase free tier is really generous. So you're going to, if you're building a SaaS that becomes successful, hopefully, you will really have to get a lot of users online to use your application every single day before you'll get near to the point where you'll be asked to start paying for your database usage. All right. Now, we'll close off by talking about a couple of things that are very, very important for us to get going or to start doing, so that we can actually start building our SaaS, right? The first one of them is signing up to GitHub. If you have not done that, you really need to start. You really need to sign up to GitHub, get your account set up, and I'm happy to do another stream outside of the weekly Saturday streams dedicated to setting up your GitHub, setting up Git, and getting your environment set up, because I think this is something that we really have to start doing going forward, right? Okay, so this kind of covers the general content for this week's slides. Again, we're not really going to do a lot of database manipulation today, just because it's not relevant to what we're currently doing immediately, right? Because we still have a bit of preparation that we need to do to start building our app properly. before we will dive into the whole database thing. All right. Now, okay. I want to actually we do still have a bit of time. Actually, we still have quite a lot of time. Shall we go through the process of setting up GitHub and Git now, so that you can maybe follow along, or do you prefer for me to start building the app in a structured way using AI now? Or we'll reserve that for next week and continue with setting up GitHub and Git and going through the basics with them. Okay. Cool. All right. Thank you very much. So let's continue with getting into GitHub and seeing how that all works. All right. So hold on. Let me go back to the browser. Actually, not here. I need my other browser. Right here. So if we go to GitHub. Okay. So what is GitHub? Maybe let's start with that. While we are building our app, right? We have all of these files here. At some point, if we want to launch our application, these files need to be deployed to a server. But even if we haven't reached that point yet, we want to keep historical points, or at least points in time that we have built something in our app. So we have added a piece of functionality, or we just build the core functionality of our app, and we just want to save it at that state, right? And then we'll continue to add another piece of functionality, right? And when we're happy with that, we're going to call that version like 1.1, for example, right? To have these iterations, right, in your application, that's where version control comes in. And this is where the power of GitHub comes in, where it provides a platform that is completely free to use and is being used by millions and millions of developers across the world to host their code online, private, or shared with the world, where everyone can just come in and copy their applications. So let me sign up. Okay, I'll sign up with Google. Just give me 1 second. Let me just. I have no idea whether there will be any private information on the screen. Okay, so let me just sign up very quickly, and I'll switch back to. I'll switch back to the screen. 1 second. Okay. Sorry, just completing my authentication here. Sure. Okay. All right. All right. So we've yeah. Okay. I've created my account. 1 second. Okay. We're in. So what do you do on GitHub? On GitHub. So after you sign up, so all I did is just created an account, nothing more than that. I just logged in with my Google account, and you can, like, of course, create one just by having your, just create with an email address and a password. Um, you can go through their playlist, which does a bit of explanation, but it's very simple. What we're going to do is a couple of things. So we're most probably, actually, let me look up some things before we get there. They're going to create your repository, but you can also, if we're going to go, actually, this is our home, but we can look for anything that we want. We'll do that in a bit. Just let me create our repository first. So the repository is just going to be a folder for your project, like we have on our local computer, right? So just like if we go to VS Code, we have this folder that's on our computer where we have all the files of our project. The same thing is true here. So we have here the user. So it always starts with your account name, and then you create a repository, right? So I'm going to call this, and the names of the repositories have to be unique, right? So you can't have multiple repositories called the exact same thing. Also, because this will be the path of your application, it can't have spaces in it. So now I've just typed humble and then space. It tells me that, okay, your repository will be created as humble with a hyphen, right? Because again, this has to adhere to the ASCII letters, so there can't be an empty space in here. So I'm just gonna say humble devs first repo, right? Now I can provide a description. Okay. We can set the repository to either be public, so anyone that is signed up to GitHub, or even not signed up, anyone who just visits GitHub and looks for like our repository or something that we mention in our code base can find this repo. Repo is short for repository, and just go through all of the files, right? We can also set it to private, so only we can see it, right? I'm just going to set this to public because, I mean, there isn't going to be anything in there that will be problematic for anyone to see outside of myself. You can add a README file by default. We're not going to do that because we'll add one ourselves, but otherwise it will just add the default README file to your project that you can just edit later on. The .git ignore is very important, and we'll cover that in a bit, right, in our code base. And the license. This is again something that I mentioned before. So if you're going to push any code online, right, no matter whether it's complete or not, whether it has value to you or not, always try to assign it a license. And the license is very simple, right? No license means that anyone can just copy your code, no questions asked, right? There are also a lot of free licenses. So you have the Apache license, you have the GNU license, you have the MIT license. There are other ones. So at the end of the day, you can choose whichever one you want. I would say just do a bit of a search regarding what kind of license is best to use by default for your use cases. We're going to stick with using the MIT license for now. Which again, you don't have to if you're just like playing around and you're pushing some code. It's just like a test project or something like that. Don't bother with this. But if you're creating any kind of project that you want to publish online, the license will put some parameters around how people can use your code, how they can redistribute it, and the fact that they have to give you credit. So they have to mention that they got this from you at some point, right? Okay, we'll talk about the Git ignore in a bit. So let me just create the repo and it will be empty. So there won't be anything in here. This is the repository, right? So we can browse back to our account just by following the breadcrumbs here. And now that we have at least one repository, you see that our home or that our overview has some information in it. So there will be all of the things that we do will come in here as a sort of a timeline, like you have for social media accounts, for example. There will be a contribution tracker. So this will show every time that you push code to GitHub when you did that and how frequently you did that. So this is something that a lot of developers find great to show off to people the fact that they push so many things. And again, it is something that is quite it motivates you to push more to GitHub because then you see the numbers go up and your board becoming green. So hopefully this will also motivate you to keep on building. But for now, is there any kind of nicer image we can select by default? No. Anyway, that's okay. So if we go to so this is our page, right? This is our home page. We can go to our repositories where we only have the one that we just created. Now, if we enter the repository here again, right, it's empty. There's not much in here. You see just the general information. And you can basically push your code from your computer to this repository, right? And this is where Git comes in. Git and GitHub are not the same. We'll explain in just a second what Git is and how that works. And this is GitHub, right? So GitHub is a SaaS on its own. Again, it's open source, it's free to use. And if we look, for example, so we're not going to look into our own repository, but we're going to look for VS Code. And so I'm searching on GitHub, right? And on GitHub, you see all of these search results, right? Where we also have a account by Microsoft for VS Code. And if we go in here, you will see that you have Visual Studio Code, right? The open source version. So this is Visual Studio Code that we use, right? Is open source. And that's also the reason why Cursor can just copy it and create a fork of it. So creating a fork of something just means that you take that and you make your own version of it, right? Windsurf does the exact same thing. So they also take, sorry, I got lost a bit. They also take Visual Studio Code, the open source one, and adapt it for their own use case, right? So Microsoft is using GitHub to publish Visual Studio Code online to anyone, right? So this is open source. If we look at their information, right? So the project information, you have the README, which is this file. So if you have a README file, this is where it will be. It will show you all of the information of the project. It is MIT licensed, so you can read a bit about. So MIT license means that you're publishing your software for free, that people can reuse it, and that people can like resell it and all these kind of things. But you remain to be like the author of the original application, and you can be credited for it and whatnot. And you can read this up on your own if you want. A couple of interesting things here. So you can watch something. So if you are interested in this, you can say, okay, I'm gonna watch this, and GitHub will send you a notification every time that there is a new activity on this repository, right? So if you're interested in updates about VS Code, you can watch it, and then when there is an update, you'll receive that notification. You can create your own fork. Again, a fork just means that you're going to copy this entire project, and then you can just edit it on your own. So I can take this project, I can copy it entirely. But when you fork it, right, you are still connecting to the original one. So if I want to maintain, if I want to keep the updates of Visual Studio Code to also apply to my fork, so to my version of it, I can get these updates as well, and I can integrate them into my own build. But also I can choose to not update it fully. So I can choose to ignore some components that maybe override things that I've already changed for myself. But it keeps me in the loop of developments that are happening with the code base that I originally copied from, right? The one that I forked from. You can start it. So this is just like, giving like, so starting it is different than watching it. So starting it means that you find this like helpful. You find this to be a good code base that you're acknowledging. So you give it a star to make it more popular, right? Because at the end of the day, stars are the only measure of popularity of code inside of GitHub. All right. Okay. One more thing. Even you, and even if you're just starting to develop anything, right? You could contribute to open source code. So this code base is online, right? Now, I'm not saying that you should go ahead and start or try to contribute to VS Code, but if you're searching for a specific SaaS or like an application idea that you're interested in building, you could even search inside of GitHub for a keyword of that application, and you might find that a lot of people have built something similar to what you're looking for. Maybe only half or three-quarter, or like just scaffolding of it. And they're like, okay, I built this because I liked it. I'm putting it online if anyone wants to continue building it or like take inspiration from it, right? Or you might even use one that is actively being developed. So someone has developed it, but they're like, okay, I'm perfectly happy with you guys copying my work and then making it your own, right? But you find some kind of limitation in their code base or some kind of problem in their code base or something that needs to be updated. And you could do that update yourself and provide them the new code. And this is where pull requests come in. So this is maybe an advanced topic, so we'll cover this later. But for anyone who has basically copied the entire repository of VS Code to work on it themselves, and they find that there is something that is broken inside of the VS Code functionality, right? They can basically fix it themselves and then choose to provide that fix to the original repository. And this is where the pull requests come in. They're like, okay, I changed your code base because I found that there was a problem with this file. There is like a typo. There is something that doesn't function as intended. And then you can provide that. And then if you look at the file changes, you'll be able to see all of the things that this person changed from the original, right? So on every file, in every line that something got changed, so you see here that, for example, there is here a typo, so there should be a double T where there was just a single T. So a whole bunch of things, right? So this guy, he like updated some files with seemingly just some improvements to text and spelling mistakes, right? And that's perfectly fine because, again, this is open source, right? So anyone can contribute to this. Now, whoever manages this repository can choose whether they accept your commits or not, right? So as you can see, there are 722 pull requests. So there are 722 requests coming from people who have, you know, downloaded this repository, have worked on it on their own. Maybe they wanted to add some functionality that they think is missing, or a functionality is not working properly, where they're working on it, or this individual where he's fixing typos inside of the repository. And whoever manages this repository can go through them and accept them or ignore them, or ask these people to change more things, or to fix maybe some things that they have broken now because of the changes that they have made. And then when they're happy with the change, and when they're like, yeah, this looks perfectly fine, let's add that because that's a good addition, they can then accept these changes, right? And this is called contributing to open source software. All right. Great. So having said all of that, let's go back to our home. So we're going back to our profile and our beautiful repository. Okay. So let me just have a look. What do I show? Okay, good. So before, let me just clear this. Clear. No, not here. Clear. Okay. Okay, I'm in the right repository. Actually, at least in the right folder. Okay, perfect. So, we need to get Git. Okay. Actually, let me close off all of these things, which is wonderful, but we don't need this around anymore. Homebrew Git. Now, I've already covered before that I have Homebrew installed, right? Which is maybe let me just explain it again very quickly. So, Homebrew, specifically for the Mac, is meant to help you install and manage third-party applications on your Mac from the command line. And this is used a lot in like development in general, just because you can like install and update all of these like small applications that don't have user interface generally, using your command line, and you don't have to like download a new version and install it separately every time. You can just you can just run a command to update your applications in Homebrew, and it will update all of them for you, right? So, what is Git? So let's install it, right? So it's just brew install Git, right? Easy. Okay. As you can see, it already tells me that I have a couple of apps that can be updated, which is fine. Okay, so that's installed. Now, it is okay. Now I'm gonna make this very simple for you. Git, similar to maybe how like Node worked, and specifically npm on our project, is used for a number of things. Git version. Okay, so we have Git installed. We have 2.39. Okay. Okay. That's interesting that whatever version it tells us is the latest is never the one that we're getting, but maybe the pages are just outdated. But okay. That's fine. All right. So Git is a version management control or a branch management control that is local, where in GitHub, right, we create repositories. We can push our code here and we can create branches. So we haven't really covered that, but we'll get there in a bit. Git does the same locally for us and allows us to push and pull our code to and from GitHub. All right. So how does that work? In our project, so we go to VS Code, we have this project, right, which is just not currently a collection of random files, not really great, but it is what it is, right? We currently don't have Git initialized in our project. So we currently don't use Git at all because, again, we just installed it, but we don't use it here for this project, which is something that we're going to use for every project going forward. When we install Git, it is installed for like on our computer in general, so we don't need to like install it separately for each project. We just need to initialize it. And if I go to my file browser, right? At the moment, so if I'm going to display my hidden file, hello? No, no, no. Okay, maybe I don't have any. Is that the reality? Sorry. Okay. Okay, I'm not sure what's happening here. Okay, I'm very sure I'm using the correct shortcut. Hold on. Maybe I'm not. Uh, maybe later. Command Shift period. Yes, that is exactly what I was doing. Okay, okay. Maybe there is no hidden file here, and that's why it's not showing anything. But okay, it will be there in a second. I just wanted to be sure. Right. So sorry. Continuing with our talk. So Git is installed. We don't have Git yet here, right? I'll upload a Git cheat sheet to the Discord server, which will show you like most of the commands that you can use, so that you don't have to like Google all of them. But all we have to do, so we're inside, so we are now inside of the folder where our application is, right? Now I'm just gonna say git init. And it says, okay, initialized empty Git repository in the path, right? So now if I go to my file explorer and I do this, yeah, see now there is a hidden file. You see that Git creates a hidden folder in your, so normally if you're just looking at the folder, it won't be visible. So you have to make your hidden files visible in order to see it. And the Git folder has a lot of information in here. So there's some configuration, there's a description, there is like, it stores all of the data in here, right? Now, at the moment, this won't really do much until we say that we want to start maintaining our files. Now, if we go back to our code editor, you see that we have now some new symbols, right? And it's currently showing us that these files all have not been committed. So if I hover over it, you see that it says that this is untracked, right? Who is supposed to track these? Well, that is what Git does. So if we open our terminal here, and again, we are inside, so we can do this separately. We can do this here, but it's better to just do it here in the code editor, just for consistency. And if we're just saying we're going to ask Git, where are we working in now? Okay. Well, there is currently nothing, so there is no information that's being stored. But again, we haven't committed anything. Now, in order for us to commit something, we can say that we want Git to add. And if we want to add all of the files that we have, we just say dot, period, right? So we want to add everything, and we press enter. Now, Git is tracking these files. Okay, index added. Index added. Now, at the end of the day, we are not going to use this. You could, right? So you could say that, okay, I'm going to use Git for local version control. So I'm going to, at some point, create a branch and I'm going to store all of these files and create copies. But that's not really what we're generally going to do, because otherwise what you're doing is like creating versions of your app that Git will track locally in your file system, which is okay. But again, at some point, we're going to have to publish this somewhere, and doing this out of GitHub will be much more beneficial for us, right? So in order to do that, let's go back to the browser. Our repository, right, will generally provide us with some guidance on how to get this, on how to get anything here. So actually, no, let's do it differently. No, cancel. All right. So let's go back to our code. Actually, I wanted to show you something. I don't know, did I miss it? Let me just create a new repo very quickly. So, interesting. All right, doesn't matter. So, repositories, we're going to create a new repository. We're going to say demo con one, right? Demo con one. This is going to be public. We're not going to do a README file, no git ignore, license, sure. So create repo. That's actually quite strange. Normally it would show you a guide on how to put your files or how to start committing to it, which is quite strange. And very maybe, sorry, I just want to test this very quickly. So our repositories, tests. So I'm not going to add a license. I just want to create this one. Okay, that's quite strange actually. Just because I selected the license, it skipped everything because I guess there's something in there. Weird. Okay, doesn't matter. So if you create a repository without a license, without anything, it will actually show you how you can get your files into this repository, which is quite easy. It says, okay, so you need to do a quick setup, all right? Now there is something that we need to do in order to authenticate ourselves first, but we'll get there in a second. So this is okay. You can download it. You can download the desktop application. Fine. We're not really going to do that. It's a bit too much. You can create files. You can update files. Beautiful. So all that we need to do, it says okay, or create a repository on the command line. So it said okay. Now you can say we have already done git init, right, in our repository, in our local repository, right? So it says you can create these in the command line, right? Which is great, but we're going to do this out of a project. But the other option is push an existing repository from the command line. We have an existing repository, right? So this is what we want to push. So we have this is a repository, but it is local that we're managing with Git. And we want to push this to this remote repository. So you see that it gives you here Git commands. So these are for Git, not for GitHub, right? It says, okay, Git remote. So this is instructing Git on our computer to set the remote repository for the local repository and add it as the origin with this address, right? It will say that, okay, the Git branch M, which is the main branch, is called main. And if we go to our, just going to open this in a new tab. And if we go to any of our repositories, you will see that the main branch is called main. So this is the default branch of your application, right? So far, so good. And it says, and it will do a push. Now the push is the command that will actually submit all of your files from your local repository to GitHub. Okay, and it says, okay, this is -u. You do only for the first commit, and then you say origin is going to be main. So where you want to store the current file set that you're sending, you want to store it in main, because if we're going to be building new functionality for our app, we will create a new branch, and we might want to be pushing to a different branch than main for building a new functionality. So let's do that. Now, in order for me to do this, I will most probably have to authenticate myself. So I'm just going to give this a try and see how we fare. Yeah, okay. So let's do, I'm just going to do this one by one. I don't want to do all of the commands in one go. So I'm going to submit this. All right. And now we have basically connected our local folder, so our local repository, to this remote repository, right? And let's set the branch to main, which is quite default, no problem. And normally, so we've already added all of the files, so we don't need to tag these. If they were still so untracked, we would have had to track these. Now, we're going to say git, no, we already did that. Sorry. Okay, so, yeah, sure. Git push origin main. All right. Sure. Any source main does not match any. How's that? Yeah, okay. Main. It's quite strange. Actually, I mean, I shouldn't say it's strange. Most probably we're missing something here that we didn't do. So we connected to the remote. I mean, most probably we've forgotten to set some global configuration for Git. Okay, so let's look at that. So if we look at our documentation, right? So if we want to set up, by the way, you can get a Git cheat sheet from here, but I mean, there is a which will give you a brief rundown, but there are better versions and more how do you call it? More structured versions that will show you quite a lot. Okay, so let's do the following just to save time, right? So in here, you don't set up Git all that often, so doing this for the first time is maybe you forget a couple of things, but that's fine. So we have our AI at our disposal, so we can just tell it that okay, we're trying to do this, and it's failing, so it can at least tell us what's happening. So we had all of this, right? We are trying to push to GitHub and are getting this error. So most probably it has to do with my with the I don't know, you know, that's how it goes. So what happened here? Yeah, of course, I added all of my files. So I did, the git add this, but I also need to commit them. So git commit. So this basically, so adding the file will just add it to your current like build if you want to see it like that. But when you commit it, that's when you're saying, okay, this version of the file, of all of the files that are currently added, I want to submit as the current version. Like I want to submit them to be the default version that we're using now. So we're going to commit, and then -m means a message. We're just going to write first commit. I'll explain later the importance of the commit message. Okay, so we get the list of all of the files that were added. So these are all of the things that have been added now to our repository. Again, all of this is still local. And now we can say git push, let's do -u origin main, right? And this is the command that will now push it to GitHub. So, okay, it's saying, okay, it wants to sign to GitHub. We're going to allow it. It's going to open GitHub, and we're going to say, yeah, fine. Oh, this is great. So in the past, you used to do this all manually. It's great that that's not required anymore. Okay, sure, works for us. Yeah, go back to GitHub. Amazing. So now we're authenticated. And this just makes sure that whenever you're pushing code to your repositories, whether you have them public or private, that this happens securely and that you're like the only one who can do it, at least to your private repositories, but also like even the public ones, like people aren't going to be able to just push to your repository without like doing it through a pull request. So okay, cool. Rookie mistakes, we all make them, so it's all good. Now, this is our repository. If we refresh it and we go to the code, you see that all of the files that we have locally on our computer, all of these, are now in here, right? And this is how we will keep versions of our app, right? We'll dive more into using GitHub, of course, as we go along. But for now, if you're like just working on a build, so currently you see that everything is kind of in here, right? Now there's a file that it mentioned that we didn't include, actually two files. So let's add these manually. So we have readme.md, and the readme.md is going to be a file that describes your application, right? And we're going to tell our lovely AI here to do that on our behalf, right? So if we're going to say that we wanted to generate this for us, we're going to do write the readme for our Kanban app, please. This is something that you would generally do more towards the end of your building of the application, because when you're building this, you will just provide like a general description of like, this is what I'm trying to build, right? But if your app has already been built, or if you have a document that describes all of the things that your application does, you can just come in here, ask your AI to write it for you, and it will go through your files and it will like reference the important things. So as you can see, it's like, okay, this is what you can do with it currently. These are the prerequisites which it got from our like files. How do you install it? All these kind of things, which is quite great, right? The folder structure, which is again like super simplistic and very amateuristic for this sample project, but it is what it is. And you can see that we have now another untracked file, right? So this is an easy way for you to know like what is currently a part of your build and what isn't. And the second file that we didn't add is the .git ignore. And this is a very important file, because as we will continue to build our app, you will become very familiar with another file that is called, and they start with a dot because these are supposed to be hidden in private files. Which is going to be our env.local. Yeah. So what are these files? So the git ignore will basically have all of the files in here that you never want to publish to the internet, right? And this is generally the let me just populate this. Okay. So what you would have normally in here, if you're building your application, you will have a lot, all right, of files that are there only for configuration, that are there only for your local build, that are only there for development purposes, that are a part of your front end or back end, that you're not going to be deploying to your like SaaS platform that's going to be hosting your application, or to a server that's going to be hosting your application. So for example, if we're using Node.js, you have like node configuration files and like debugging files and error files and whatnot. All of these are not required to publish anywhere, because these are only for your development purposes. If you're doing any kind of logging, the environment variables. So we haven't put in environment variables. We haven't even spoken about environment variables yet. But an environment variable is basically just an access token or an account or something like that that you need to like authenticate something. We'll do that as soon as we start to include our database. Because to connect to our database, we need to tell it the server, like our database server that we're connecting to, our credentials. And all of these, we're not going to put in a script of our application. So all of these are environment variables. And again, like we haven't really worked with them yet, but we will very soon. So all of these, we don't want ever to send to GitHub. So these are things that we will add to our deployed application, again, as an environment variable, which will be a hidden file, hidden securely, so that only the backend, so only the server components of our application can access these, right? So here there are a whole bunch of configuration files that are only there for your own workspace. And again, like this is just a template, right? So it's listing a lot of things that we don't have in our application. It's just like putting in here whatever is commonly inside of a git ignore file. And the git ignore file will tell Git. Okay, so this is why it's called the git ignore file. So it tells Git that whenever we're pushing this code base to our repository, that all of these files should be ignored from the push, right? That's why it's git ignore. So all of these files, whatever you put in here, so even if you like put in here a folder for your like project configuration, you can just ignore the entire folder, and that configuration just stays on your computer, right? If you don't want to publish this. So now if we say, so we're gonna git add everything again. So git add dot to add all of the files. So all of them become, tracked, right? So they have been added to the index. And then we have to git commit and then -m for message, adding. So the message itself is quite important. So in here, you want to provide context to what you did or changed to your application for this very specific commit. So at the moment, it's like very basic stuff, right? However, if in the future you're building your app, right, and you've already committed 50 times, you've added a component and it broke something, and you only found that out later. So you already committed, you already pushed, and then you test your application and you're like, this is now broken, and like you're having a hard time troubleshooting it. So you're like, okay, let me uh, revert back all of the changes. And if you didn't commit with a message that clarifies that, okay, this is when I committed that part of the code, it's going to be quite difficult for you to know where that point was in time and how to revert back to it. So that's why giving just a brief description of what is the most important change that you made for this specific commit is going to be very, very important for you in like understanding all of the changes that you made over time to your application. So in here, I'm just going to say adding readme and git ignore file. Okay, and close it. So these are between quotes because this is a string, right? So we have to put it between double quotes. And we're committing. So now it shows us all of the things that have changed. So 2 files have changed. We have so many insertions, which is great. And we're going to again push it. So git push origin main, right? So we don't need the dash, the -u, and it's going now to push it again to our GitHub. And if we come back here and we refresh, our README file will automatically be populated here. So if we give it a second. Yeah, okay, so you see the git message is here. So adding readme file. I don't know why readme is not visible. We have something in readme, right? Yeah. Is it being ignored maybe? No. I mean, it's here. but it's empty. Did we not accept the changes? Readme. We did, as far as I can tell. Maybe we didn't. Okay. This is quite strange. Okay. How is this readme? Oh, no, that's all fine. Did we? What did I modify here? No. Okay. Git commit. Git push origin main. Not sure if our file was broken. Yeah, really strange. Anyway, so the readme file is here now. All right, so I don't know, it was somehow not saved properly, but it's here now. So it will render your README file automatically as your first file. So the README will automatically become like the description of your repository. And you see that all of the files are here. You can even open them, so you can just click on the file and actually see it. And you can even edit it here. But again, considering that we're doing the edits on our in our code editor, we normally shouldn't really be playing with it here. And you can also do it the other way around. So if you have a repository that you gotten from somewhere, so if you have any repo that you see that you're like, this is quite a cool thing that I want to continue building on, then you can do the opposite. So if you go to your code base, which we're already here, and you go to your code, you can use your you can use Git to clone the repository. So instead of pushing it, then you would tell Git to clone the repository to your local folder, and then it will get the files from that repository and automatically connect to it. So that becomes the repository that you're then pushing to. So normally, if you're getting it from somewhere else, so if you have a repository that's like not by yourself, not the one that you created, you would fork it, and then you can then just pull, or at least you can clone the repository locally to your computer. This will automatically also connect it to that repository, and then you can just continue working like I have here. So you can make your changes, start doing the build, and then moving on from there, right? Next session will also be diving into using the branching. It's not complicated, but there are a couple of things that you need to understand about it, because it creates a tree so that you have your main, and then you're like, okay, I've created the basics of my application. I now want to add, for example, I don't know, I want to add authentication. I will create a new branch. I'll call it authentication, right? And then I'll develop only in that branch. So I'm pushing to that branch. I'm not pushing to main. And only when I'm happy with the authentication method that I've added and I've tested it and it works fine, then I will merge the two. I will basically be fusing the main and the authentication branches together. And that will become then my main branch again. So the main branch will then have the authentication functionality as well. And if after adding the functionality, I'm like, okay, now I want to add, another piece of functionality to my application that is in there now, I'll create a new branch to develop that part so that my main can be fully functional and can even be deployed. So my application can be like online available and people can use it. And I have a different branch that I'm using only for developing a new feature or new functionality. And then when I'm happy with it and I've tested it and it all works just fine, I can merge the two again. And then my main app will then have new functionality, right? So this is where branches come in, and this is very, very important, and this is also one of the powerful things for GitHub and Git in general, because it will allow you to like keep your application like it is and add new functionality. And one of the things that you might have seen, so now we've added this again, like this is like really a very bad repository. But it even shows you a breakdown of your code. So it says that, okay, 70% of the code that we have is JavaScript. Some of it is CSS and other bits are HTML. And depending on your application, this will, of course, be reflected accordingly. So this will cover it for GitHub as well as Git. I really, really advise you to get GitHub set up as well as set up Git locally using Visual Studio Code. Play around with it. Do a little bit of foundational building. I will most probably do another stream tomorrow. That's going to be not your typical weekly structured one with the presentation, but just like a working session somewhere tomorrow evening so that I can show you how we are going to start actually building our application, because we do need to do a bit of preparational work. And to go through that, there is a bit of explanation. There is some examples that I want to give, and I want to do it like more practical. So I'm gonna host another stream to go through that specifically. What we do, what we use, how we set up rules within Visual Studio Code, to actually start building our application in a way that will be able to maintain it, that we decide upfront what it is that we're going to do with our application and how we want to build it, the technology that we'll use, and how we use, of course, very importantly, how we'll use AI to document all of that in a way that AI can help us to actually build it. All right. So having said that, if there aren't any specific questions that you guys want to ask right now, we'll call it done for today, where we've covered some aspects of database. Again, we haven't gotten there yet, but we'll get there shortly. We've set up our GitHub as well as Git. We've pushed something from our local computer to GitHub. Nothing great, but that will happen very, very soon. Don't worry. But yeah, this works, and as you can see, it's very easy to set up. It used to be quite a bit more complicated than this in the past, but I'm happy that it isn't anymore. So it's very easy to jump into, as long as you have your GitHub account created in advance and you get your GitHub set up, then you'll be good to go. All right. So looking forward to seeing you guys again on the next stream. This will do it for today, and see you on the next stream. All right. Have a great day. Take care, and until next time. Bye bye.